Welcome to the DIY Honda Garage channel. The DTC P2182-1C indicates an issue with the Engine Coolant Temperature (ECT) Sensor 2 in a Honda CR-V 2023 or newer. This specific error arises when the output voltage of ECT Sensor 2 is found to be outside the specified range, which is critical for the proper function of the vehicle's engine management system. The Powertrain Control Module, PCM, records this fault code to alert technicians to a potential malfunction in the cooling system's temperature monitoring. ECT Sensor 2 plays a vital role in measuring the temperature of the engine coolant, which ensures that the engine operates efficiently and prevents overheating. The sensor is typically located near the engine block, connected to the cooling system with wiring leading back to the PCM, which processes the sensor's data. Regular monitoring of this sensor helps maintain optimal engine performance and longevity. The error code P2182-1C signals an anomaly related to the Engine Coolant Temperature ECT Sensor 2, which is essential for the vehicle's cooling system. This sensor is responsible for providing real-time coolant temperature data to the Powertrain Control Module, PCM, enabling it to make adjustments for fuel efficiency and emissions control. The ECT Sensor 2 is typically positioned near the engine block, where it can accurately gauge the temperature of the coolant as it circulates through the engine. If this sensor's readings fall outside a predetermined range, it triggers the PCM to log the DTC. This means that the engine may run inefficiently, leading to potential overheating or poor fuel economy. Therefore, detecting issues with this sensor is critical to maintaining an efficient cooling system. When diagnosing the DTC P2182-1C, there are several potential causes to consider. The first and most common is a faulty ECT Sensor 2. This could result from wear and tear over time or exposure to extreme environmental conditions. Another possible cause is a shorted wiring issue within the circuit, particularly in the connections between the sensor and the PCM. Damaged or corroded wiring can lead to misleading voltage readings, prompting the PCM to log this DTC. Lastly, if both the ECT Sensor 2 and its wiring are found to be functioning correctly, the issue may lie within the PCM itself, which could be malfunctioning or misinterpreting the sensor's signals. Evaluating each component in the system is essential for accurate diagnosis. The symptoms of a malfunctioning ECT Sensor 2 under the DTC P2182-1C can lead to significant operational challenges. One major symptom is engine overheating, as the PCM may not receive accurate temperature data, leading it to mismanage engine cooling. This can escalate into severe engine damage if not addressed promptly. Additionally, poor fuel economy is another common symptom, since the PCM relies on accurate temperature readings to optimize fuel mixture and ensure that the engine runs efficiently. Drivers may also notice warning lights illuminated on the dashboard, alerting them to engine-related issues. These signs indicate the need for immediate inspection and diagnosis to prevent further complications and ensure the vehicle's longevity. The first step in troubleshooting the DTC P2182-1C involves preparing the vehicle for diagnostics. Start by turning the ignition to the on mode, which allows the onboard systems to activate. Following this, you will use the Honda Diagnostic System HDS to check the value of the ECT Sensor 2 voltage. This value is crucial. It indicates whether the sensor is operating within its normal range. A reading above 0.16 volts signals that the sensor is functioning correctly, while a value below this threshold points to a potential fault with the ECT Sensor 2 itself. This preliminary checking sets the groundwork to verify if the sensor requires replacement or if the fault lies elsewhere in the system. In the second step of the troubleshooting protocol, you will focus on inspecting the ECT Sensor 2 to ascertain its functionality. Since there is no direct method to test the sensor alone, this involves removing the sensor and checking it against established benchmarks to determine its operational status. This procedure typically requires examining both the sensor and the wiring harness connected to it. If the sensor checks out correctly, the next step is to look at the external circuit linked to the sensor. Ensure that the wiring leading to and from the ECT Sensor 2 is intact and free of wear, shorts, or other electrical issues that could mislead the PCM regarding coolant temperature. This step is vital for ruling out external component failures before further investigation. The third troubleshooting step involves a close inspection of the TW2 sensor wiring to verify its integrity. Before disconnecting the PCM connector, ensure that you have followed safety protocols by jumping the SCS line with the HDS and waiting for more than 1 minute. With the ECT Sensor 2 connector and the PCM connector disconnected, you will now focus on inspecting the wiring for any shorts, breaks, or other circuit-related faults. This inspection looks for signs of wear that could lead to the sensor being shorted to ground or exhibiting incorrect values. According to the diagnosis procedures, the acceptable norm is more than 1 megaohm of resistance, ensuring that the wiring can carry accurate signals without interference. If there's a fault in this circuit, replacing damaged wiring or connectors will be necessary. In the fourth step of the troubleshooting process, the focus shifts to inspecting the powertrain control module, PCM itself. If the earlier inspections of the ECT Sensor 2 and the corresponding wiring yielded normal results, it is now plausible that the PCM is at fault. The PCM acts as the central computer, processing all data from various sensors, including the ECT sensor. Any discrepancies in its performance could lead to improper engine management and efficiency issues. You will need to verify that the PCM settings and functionalities align with factory specifications and that it can accurately interpret data from the ECT sensor. This entails using diagnostic tools to assess the PCM and confirm whether it requires servicing or replacement if found faulty. Once all repairs related to the DTC P2182-1C have been conducted, it is crucial to implement a final verification process. Start by rechecking the status of the ECT Sensor 2 to ensure it is functioning as intended. Next, run the engine and monitor its performance closely. Look for any symptoms related to previous issues, such as abnormal temperature readings or warning lights. After allowing the engine to reach normal operating conditions, clear the DTC from the PCM using the HDS. Finally, conduct a retest to ensure that the DTC does not reappear, confirming that the repairs were successful and the system is now operational. This validation step solidifies the integrity of the repairs made during the troubleshooting process. To prevent future occurrences of the DTC P2182-1C, implementing a routine preventive maintenance schedule is essential. Begin with regular inspections of the ECT Sensor 2 to ascertain that it is operating correctly. During these inspections, also monitor coolant levels, ensuring they are maintained within the recommended ranges to prevent overheating. Additionally, examining the wiring harness for signs of wear or damage can help prevent electrical faults that may arise from poor connections or shorts. By keeping these components in check, vehicle owners can enhance their engine's operational reliability and extend the lifespan of their cooling systems. Adequate maintenance serves not only to mitigate risks, but also ensures optimal running conditions for the vehicle. In summary, the DTC P2182-1C highlights a critical issue regarding the Engine Coolant Temperature Sensor 2, which can lead to serious engine complications if not addressed. Vigilant monitoring of sensor performance and vehicle symptoms is vital for timely intervention. It's crucial to follow a comprehensive troubleshooting approach that encompasses checking the sensor, wiring, and the powertrain control module. Addressing symptoms promptly can mitigate risks of overheating and poor engine performance, thereby ensuring the longevity and reliability of your Honda CR-V. Adopting preventive maintenance practices will bolster the effectiveness of the cooling system and enhance overall vehicle performance, allowing for a smoother and safer driving experience. Please like and subscribe to the channel. See you next time.